All right, so hello and welcome back to our stream here at OneClass. Again, my name is Joey. I'm going to be your chemistry teacher for this session. Today is Thursday, so I'm going to be streaming some chemistry problems for you folks at home. If you're tuning in for the first time here at OneClass, well, a little bit about ourselves. So what we're doing here is we're creating some live streams and videos for you for basically frequently asked questions. And these questions are submitted by folks like you at home, students like you at home. And what we're doing here is as OneClass teachers, we are verifying these solutions to provide you the best kind of results as you move forward in terms of your tests and assessments. So throughout these questions, we'll be teaching you the concepts behind the question, and then so that you'll be kind of better prepared for when classes do start again, when you're back in school, like physically. So here at OneClass, what we're doing is we're providing these free online resources for you to access basically anytime at youtube.com/OneClass, and you can find out all these videos are already recorded as well, and you can join us in the, on the live stream as well if you want to kind of tune in live. So just a little bit about myself. Again, my name is Joey. I'm currently a secondary school educator in Ontario, and what I'm doing is my teachable subjects are chemistry and also and music as well. But I'm planning to get my math teachable further down the road as well. So without further ado, let's get started on kind of today's lesson and what we're going to do. Today is probably focused on, I have like one grade 12 chemistry question in terms of the senior level, but most of my questions here are going to be in the grade 11 curriculum or the first half of general chemistry. So let's get started here. All right, so what we have here is it says determine whether HI, so hydroiodic acid, can dissolve each metal sample. If it can, write a balanced chemical equation and showing how the metal dissolves in HI and determine the minimum volume of 3.5 molars of HI required to completely dissolve the sample. So we're given basically, we're given hydroiodic acid. Let me write this down here. So notice number one, we have 3.5 molars of HI, and this should be an aqueous solution. So we know it's hydroiodic acid, and we are given basically three metals. So A here is aluminum. So we have 2.5 grams of aluminum. B here is we have copper, Cu, and then this would be 4.85 grams. And finally, C, we have, this is silver, and we have 2.42 grams here. So it says here, determine whether or not HI can dissolve any of these metals here, right? So when we talk about this concept of dissolving metals, of reacting with metals, we have to talk about this concept of the reactive series, right? And unfortunately, because we have it's not a displacement activity series like you see in a single displacement reaction, because we don't have a metal displacing another metal, right? And the iodine here is, the iodine in hydroiodic acid here is a non-metal. So what we have to do is we have to actually look at our standard reduction potentials, and I kind of brought it up here as well. So you can kind of look at the half reactions in terms of the standard reduction potentials, and look at your potential as well, and see whether or not this reaction will take place. So let me write down these values for you. So I have HI here, which means I have to go in terms of my half reaction here, and I'm finding iodine. So I know here iodine 2 here, I2 plus 2 electrons here. When it becomes oxidized, I would get 2 iodine with the negative charge here. So this is the iodine anion here. So this is a reduction, not oxidation, right? Because I'm gaining electrons here. So these are all standard reduction potentials every time I gain an electron here. And this says the iodine here is positive 0.5355. If you want, you can also write out the reaction here. If you were curious here, again, HI dissolves into basically H2 plus I2, and this here obviously have to balance chemical equation here, and then obviously I2 here would then be reduced, right? So I would gain 2 electrons here, and it would become I minus here. So this here would be this here would be the reaction that would happen here. So again, I have a 2 here as well, and this here again positive 0.5355, right? So positive 0.5355. So basically what I'm doing now is I have the standard reduction potential, and I'm looking at all the other standard reduction potentials for aluminum, copper, and silver. And if it lies basically below this below the standard reduction potential, then then I'll be able to dissolve the metal, right? So let's look at aluminum here. Aluminum first lies on, let's see, Al lies over here, right? It's a negative value here, negative 1.662. So knowing that here, I'm going to write here negative 1.662. And this is simply just the reduction potential of aluminum here. I'm going to try to find copper. Copper here is, depending on what charge it is, it would probably be a different yeah, copper here would be I think they just had the 2+ here. So the copper here is 2+. This would be positive 0.337. So this is positive 0.337. And then finally for silver, I would have silver here would be over here, right? This is 0.7996. So this is positive 0.7796, right? Yep. 7996, sorry. 0.7996, and basically we're looking at these standard reduction potentials here, and we're looking at which one is furthest apart from positive 0.533 in terms of difference, the difference here, and we're going to realize that the difference here is aluminum here, right? The difference between 0.5335 and what negative 1.662 has the greatest difference here, which means it's going to dissolve a metal. So aluminum here is our correct answer. So I know it's going to be A. So I know it's aluminum, and it says here I have to write out the balanced chemical equation. So let me just do that real quick. So if I know it's aluminum, then I have a, so I'm going to have hydroiodic acid. Hydroiodic acid plus, this is aluminum, right? Plus aluminum here. It's going to react and form, let's see, aluminum. You would probably get aluminum hydride and aluminum hydride, and just the I minus, sorry, the iodine and ion here. So this would react to probably form, would be aluminum hydride, AlH3, and you would get the iodine negative here. So you get probably, if I want to balance this out, you would get something like this. So 3 iodines here and 3 iodines here. And then, again, this would be, again, oxidation reaction, so redox reaction here. And we're given here we're given 3.5 molarity of HI, right? And I want to dissolve 2.15 grams. So what I have to do is, again, I have 2.15 grams here. This is in moles. I would have to basically figure out, or sorry, mass, sorry. So I have to basically figure out the moles of this solution here, right? So again, I can figure out my molar mass if I were to look at my periodic table. So if I look at my periodic table here, aluminum has a molar mass of 26.982. So this would be molar mass here. This is 26.982 grams. And then I can figure out my moles, right? My moles is simply just my mass divided by my molar mass. This is 2.15 divided by 26.982. This would give me a value of 0.07968. 0.07968. So this is in moles. And basically what I want to do is I want again, my balanced chemical equation, I'm going to have 3 I'm going to have 3 the coefficient here is 3, right? So I have to figure out a mole to mole ratio for this HI here, which means I would have to multiply this mole ratio by 3 in order for us to get the moles of HI here. So if I were to do that and multiply this number by 3, I would get, this would be 0.2323905. Remember, this here is separate. So this is the moles of HI here. If I have the moles of HI, what I can do is I can now solve for my volume, right? I know my concentration equals my moles over volume. So concentration here is 3.5 molars. I'm going to have my moles here, which is 0.23905. And I'll have to solve for my volume here. So I simply have to just, we're going to have 3.5 V times V equals 0.23905. And finally, volume would just be 0.23905 divided by 3.5, which would give me a volume of 0.068 liters. I could convert that to milliliters by multiplying by 100, which means I only need 6.83 milliliters for me to dissolve my acid, dissolve aluminum in my acid here. So this here is the correct answer, 6.83 milliliters here. And I don't think that this is an incomplete solution here, because they didn't really show me the balanced chemical equation or the actual answer. So I believe that their logic is right here, where it says they're finding the molar mass and they're calculating the moles, but I don't think they actually gave me the answer. So I'm gonna write here solution is incomplete. Aluminum would be the one that would be dissolved. Aluminum would be the metal that is dissolved. The volume that is needed would be 6.83 ml to dissolve. This would dissolve what's the mass here? Mass was 2.15. To dissolve 2.15 grams of Al here. So again, I think their logic here was right when they were trying to find out what kind of like logic when we're approaching the answer. But I believe that they had the question wrong here. So that's kind of so they simply just missed out on the concept here. I think I'm looking at my balanced chemical equation. I don't think I actually get aluminum hydride here. I think I get I'm pretty sure I get aluminum iodide and H plus actually, and hydrogen gas here. So this is actually an incorrect thing here. I'm just looking back. I'm like, oh, this is aluminum. Here's the 3+ charge is going to go with the negative charge, obviously here. So this is my fault. This should be Ali3 plus H2 gas. So this is actually going to change my coefficients here. So that's not good. So I'm going to have here, this would be a 2, this would be a 2, this would be a 3 here, right? And then I would have to have a 6. Yeah, so 6223 would be my balanced chemical equation, which means actually my moles of this will change. Let me just check here. 6 iodines. Yeah, so actually my moles are going to change here, because I'm going to have to basically divide this moles by 2 to figure out the aluminum, and I'm going to multiply by 6. So just give me a second here. 0.07968 divided by 2 times 6 here would give me 0.23905. Oh, so this is actually the same thing. 23904, which is actually so my volume here is correct, just because I got lucky, and the multiple ratio was still 1:3. However, I wrote my balanced chemical equation wrong here. So let me just correct this here. But the volume is correct. And then I'll write here the balanced chemical equation is 6Hi plus, this would be 2Al, yields 2Ali3 plus 3H2. So this here would be my balanced chemical equation. So solution here is, I'm going to write here incorrect because it's an incomplete solution here.